We're now going to spend some time giving an overview of SpringWebFlux. SpringWebFlux is a reactive variant of Spring Boot. And as we'll see, it adds some capabilities that go above and beyond what we've learned about so far. So if you recall, when we talked about Spring Web MVC, we talked about how it's built on top of the servlet API, and it uses synchronous blocking IO with one request per thread model. And what we're going to do now is we're going to talk about the reactive stack. So that was the servlet stack we looked at before. Now we're going to take a look at the reactive stack. And as we'll see, it's a non-blocking framework that's going to be designed implicitly or inherently or intrinsically to take better advantage of multi-core processors and be able to handle much larger numbers of clients. And we'll talk about how and why it does that in a second. So again, here's SpringWebFlux. You could read about SpringWebFlux here at the link at the bottom of the slide. So SpringWebFlux is a non-blocking web framework. And what we'll see what that means is it really does non-blocking asynchronous operations all the way down to the IO layer and the demultiplexing layer that's nestled deep in the bowels of the underlying Spring Boot 2.0 framework. And it's designed to leverage multiple cores. We'll see how that works. And it also is designed to handle a large number of concurrent connections. And the reason why it is designed to do that, or the way it achieves that, is it does not have a thread per request, which was kind of the model that was used with the Spring Web MVC-based approach. One of the things that's really interesting about WebFlux is everything is handled in a very asynchronous or an entirely asynchronous and so-called lazy manner. And at first, this seems a little bit non-intuitive, but it's actually really cool. And it makes it possible to get much better scalability on both the client and the server side without using as many resources. So what you do here, kind of following along with our flight listing app, is you might make a request to get a list of flights, or as we'll see, a flux of flights. And what you're going to do is you're going to have the whole client and server model not block. So the threads that service the requests and the said threads that service the responses don't block directly, thereby making it possible to have a much larger number of requests that are going on without chewing up as many threads. You can have a much smaller pool of threads, and they can work on the various operations in an asynchronous manner. So one of the benefits, as we'll see as we get further into this, especially when we start comparing and contrasting WebFlux with Web MVC, is you need a much smaller number of threads. And that has all kinds of good benefits, especially on modern multi-core processors. Typically, the number of threads that you need is something on the order of the number of processor cores. There's plus or minus some small amount either direction. But in contrast to what we had earlier with Spring Web MVC, where you needed a thread per request, where if you had a lot of requests, you'd quickly run out of cores to handle those threads, we can keep a much, much smaller number of threads. Now, why do you need more than just the number of cores, you might ask? Well, because IO-bound operations may require the underlying thread pool to adaptively increase or decrease the number of threads based on IO-bound workload. And this is a very interesting concept. I talk quite a bit about it in some of my other courses. I'd be happy to go into it to whatever degree of detail you'd like to learn about it here. And this capability basically allows the number of threads to increase when there's lots of blocking, but then the threads go away when there's periods of non-blocking, thereby freeing up those resources, particularly the operating system kernel resources that would otherwise be devoted to managing lots of threads that could be used for other things. There's also a need in any system that's based on a reactive style model for some kind of back pressure to deal with the fact that you have a lot of non-blocking operations. And in particular, the issue here is that you have event rates that, if you're not careful, will overwhelm the subscribers or the consumers by having the publishers or producers generate requests faster than the consumer or subscriber can keep up. With SpringWebMVC, in contrast, as we'll see when we get into the comparison in just a bit, you don't really have the need for this back pressure capability because the calls are kind of inherently blocking and synchronous, and therefore you have sort of a built-in rate limiting mechanism because you have to wait for the response to come back before you can issue the next request. But in an asynchronous and non-blocking environment, such as what WebFlux provides, you don't have that luxury because you can generate requests very quickly. So one of the things you'll see with SpringWebFlux is this ability to have mechanisms in there to increase the or to control the rate at which things are sent. Now, you have to be careful. This is not so much the rate in terms of 5 times a second rate. It's more in terms of the number of requests that can be outstanding before you get the next chunk of things to send. So that's really what we mean by rate here. It's a little bit confusing if you're familiar with network congestion control or flow control concepts of rate control. It's not quite the same thing. Some of the really cool stuff that comes when using SpringWebFlux is the ability to do network communication using reactive types provided by Project Reactor. And Project Reactor is one of the very popular reactive programming frameworks. Another popular platform is RxJava for a variety of reasons, mostly having to do with wanting to use a more modern basis of reactive programming than Java 6, and instead use modern Java, Java 8 and beyond. WebFlux and Project Reactor use a more modern version of Java, whereas RxJava had to emulate certain things, and it's not quite as well integrated into the modern Java ecosystem. But the two key capabilities that are provided are monos and fluxes. And the way that this works, and we'll talk a lot more about this when you watch the other videos that go along with the course, you'll see a lot of this stuff. There's data sequences of 0 to 1 elements, which are called monos. And then there's also sequences of data from 0 to n, which are called fluxes. And here's just a very, very simple example, or a couple of examples from the flight listing app, the FLAP program, where we might have a method called find departure dates, where you're going to give it a departure airport and arrival airport, and you want to get back a flux of dates for when it goes from that departure to that arrival. And a flux, as we'll see here, is basically a data type that can be streamed asynchronously. So it's not an all or nothing proposition. The data is basically emitted as it's produced by the server, and then that information flows back to the client. There's also a similar concept called a mono, which is a little bit like a Java completable future, where you get a result back, and then you can basically wait for the result to emit when the data is available. But in this case, there's only either success or failure. You either have data or you don't. And in this context, there's a method called getRate as an example, and we give it a string that corresponds to the currency that we're converting from and the currency we're converting to, and it gives us back a mono. And when that result is ready, then we get essentially notified and the result will emit. So both of these mechanisms, monos and flux, gives us ways of being able to get back essentially a future that will emit the results when they are produced by the server. There's also a large number of operators, which you'll be learning about as you watch the videos and other parts of the class, that are aligned with the so-called Reactive X vocabulary of operators. And you will learn more than you ever possibly wanted to know about Reactive X and the various operators that are defined there as you watch the videos over the next few weeks in the asynchronous part of the course. So what makes fluxes so cool? Well, you can basically use them to stream responses element by element. So here's a very simple example, and Probably next class, we'll start diving into this reactive microservices implementation that uses all these cool capabilities to good effect. So in this particular case, you make a request for airports and you get back a flux of responses, which are the airports that are known to the server, and they come back kind of asynchronously. You don't have to wait for them all to show up. And as a consequence of using these reactive types that we get from Project Reactor, clients themselves can be more responsive. And that's because they don't have to block waiting for all the data to be coalesced together on the server side and sent back in one fell swoop. So that's a very nice capability that we get with fluxes that we do not get with the other approaches you see with SpringWebMVC, like lists and collections and stuff like that. Unfortunately, and this is kind of a shame, Android at the moment, and this conceivably could change over time, lacks support for fully reactive clients. So that's kind of a shame. You end up having to send back essentially lists that return through monos. So there's a bit of asynchrony there, but it's not quite as cool as fully reactive clients. And that's just an Android quirk. And we'll talk more about this when we get to the end. We'll be done in just a second. You could also keep the stream of events that are flowing from server to client live using something called server send events. And so in this particular case, you can put an annotation that says, I will be streaming back these results as they show up. And so basically it's telling the client and the server, keep this connection open, because a lot of stuff could be coming across that over time. So what does this actually buy us? Is it a win? And the answer is often, yes, it is a win. And you can take a look at this article here for some benchmarking results that'll give you a better impression of how things work. And the reactive stack can have a better response time, and it can also handle more requests per second. And the reason for that, again, is it does threading in a totally different way, which we'll talk about more in the next set of slides. And it uses many fewer resources. And also, importantly, in some environments, you don't have to wait on the client side for the server to do all of the processing and then send back the results as one big giant list or collection. You can get the data back in dribs and drabs as it is produced, which can make your client appear more responsive to end users because you're giving them results incrementally. So that's the end of the overview of SpringWebFlux.